Wait, I know what you're thinking, but this circuit is not as complex as it seems. Let's break it down.
So right here you can see we have an NE555 and we have connected the NE555 in a stable mode. It simply means that we have connected it to give a oscillatory signal which will going to act as the clock of our circuit, and this is how you connect it. Next we have our main IC right here, which is the S74LS195. It's going to be register 1, and right there on top we have our register 2. It's the same IC 74LS195. So how have we connected it and how are they working? So let's break it down. So this is IC 74LS195, and how we have connected the IC is to give a parallel input and parallel output. So what's the purpose of the IC? The purpose of the IC is just to store. You can just store a data like 1001, and we can read from it once we want to read from it. And we have two of these ICs, so we want to connect them in a way that will have a single data line where we are going to use the data line for input or output, and we are going to have another control where we are going to have a read and write enable, which are going to be controlled by a decoder. So the function of this connection is to choose whether we want to read or write data from register 1 or register 2.
To further explain the circuit that you're seeing on the breadboard and how it functions, we have built this is a simple schematic diagram for you to understand very easily, but there are a lot of circuitry which are not shown in this schematic, and I'm going to show you just right now. So what you're seeing here, just two registers which we are using IC74LS195 register in parallel input parallel output mode. So what we have here, for a single register like this one, you can see it has only single wires, and these wires are used as both input and output. Wait, what do I mean? So let me show you the connection for a single register. So this is the connection for a single register and how it looks. So as you can see in those 4 bits, we have the input A, B, C, D, and the output we have connected it to the input using BC547 transistors, which is an NPN transistors. And these transistors at the base pin is where we are going to control what we call the read enable. So the function of the read enable will help us to use these data lines or these lines to be used as output. When we want to read what we have stored in the registers, they are going to be used as output, not as input. Right above here you can see we have write enable. So function of the write enable is when we want to reset everything that we have on the single flip-flops, and we want to write new data or to feed new data using this line. So at this point these lines are going to be used as input, not as output, and it's not very good configuration to activate both write and read enable, because it can get messy in the bits, and some of the information may be lost if you are storing something or but if you're building this at home, try it out, activate this and activate this, and see what happens, and you can write in the comment section. So for the write enable, how we have connected it is in this diagram that you're seeing here. So here this is a pin out of the 74LS195, and this is pin number 1. So since pin number 1 is active low pin, we are going to put a switch and we're going to connect it to ground. Once we press this switch, it's going to go low, meaning that it's going to be activated and it's going to reset. This is a master reset pin. So once we press here, it's going to be low in this side, and the low this side means it's going to be high, because you can see this node here, it's an active low pin. Yes. So once you press here, it's going to overwrite everything that we have in the individual flip-flops, and now you can feed your new data using the data input lines, which are pin number 4 to pin number 7, and output pin number 15 to pin number 12, but we have connected them together using NPN transistors. So this is basically what we have connected. So in the schematic that we had down below this paper, it had you could see a single register which has single lines from it. But in normal conditions, the IC has 4 input lines and 4 output lines, but we have connected them together in order for us to have only 4 of them to minimize the number of wires. So we have only 4 of the wires used as both input and output when we want to read or write data from the register. So these 4 lines, these four inputs or 4 lines that we have connected them to the other register. So these two registers have what we call a data bus. So this is a data bus where we can feed data to either of the registers. But for that state, when we want to feed data to either these but not this one, we want to read data from this one and not this one, means that we have to include another circuitry right down here. So this for the first register, we have the write pin and the read pin, and for the next register we have the write and the read pin. So this connection is controlled by what we call a decoder. So this is a decoder connection, and using only two control or 2 switches, we can either read or write data from either of the flip-flop. And I've break it down in my circuitry. I break it down into this. So if I want to write data to register 1, I'm going to put 0 0. If I want to read data from register 1, I'm going to put 1 0. If I want to write data to register 2, I'm going to put 0 1. And if I want to read data from that register 2, I'm going to put 1 1 in the control where we have our decoder. So using only these 2 inputs, A and B, right here, A0 and A1, we can control whether we want to read or write data from either this register but not this one, or this one but not this one. So I hope you've really understood what we have in our breadboard. And now it's time for us to bring it and let's check it out and how it works. So I'm just going to slide it for us to see it. It's not as complex as you think. It's not as complex. It's only that it has different compartments, and when you break it down, it just becomes easier for you to understand. So let me just power it, and so that we can start in this circuit. So let me start by turning this off. We want it to start at 0 0 so that we can understand what we have in our breadboard. So right here, as I said, this is the clock. This is the first register, register 1. The second register, register 2. They have a single data lines. It's not possible to see them because I've not used different wires. They're almost all of them are white, but this is the data line, the data bus that we have used as both input and output. And right here we have our decoder, this one that we are talking about. We have our decoder circuit right there. So these LEDs are going to show us what we have in our first register, and these LEDs are going to show us what we have in our next register. So we are going to start off with a simple code like 1 0 0 1. I hope you can see it. Let me just put it on the screen. 1 0 0 1, like that. Okay, so 1 0 0 1. We want to feed 1 0 0 1 to which register? Let's start with the first register, register 1. So for us to write data to register 1, we put 0 0. So this is the control. This is the control of the decoder. So we put, so it's already at 0 0. So we are writing data to register 1, and our data is 1 0 0 1. So let's just do it. So we have 1 0 0 then 1. Now okay, let's now check it out. So it's not possible. Okay, you can see the, if you can just focus, you can see that the 2 reds are the ones which have been lighten up. So let's read from that register and try to see if it has stored the value. So when we want to read from register 1, we are going to put 1 0 in the control. So I'm just going to put 1, so 1 0. So 10 is in our control. Let's turn off the input and check if it has stored 1001. So let's just turn the input off like that. Now let's see, it has stored 1001 like it's supposed to. So that's how you can, so that's how it has stored them. So that's how the register works. So it has stored 1001. Let's feed a different data like 1100 in our register 2. I've configured the register 2 why it's turning on all the LEDs. It's a number of there's a transistor here that I've used that is not really an NPN transistor, but it's quite messing up with the output, but it's just going to work the same as the first register and how it works. So let's just put the data. We are going to write, we have said that we want to write 1100 in our register 2. So we have to put 01 in our control, in our this point 01. So as you can see, I've turned 00, so the input here are off, all of them, because 00 is for writing data into this register. So it has cleared what we had in our register in order for it to store a new one, but we don't want to use it right now. We want to do with the register 2. So we are putting 01, and let's put the data. So the data we have said is 1100. So 1100, and we are going to come here. Okay, so the data, okay, 1100 in our register 2. We want to read the data and see if it has stored that value. Just ignore the transistor which is messing up with the, you can see it's going with the clock, but that's not how it is supposed to behave because of this small transistor that is synced out here, this one. Okay, so let's try to read data from that register. So when we want to read data from register 2, we put 11. So let's put 11 here, 11 in our control. Okay, let's just try to put it like that. Okay, so the data that we have in our input is 1100, and now we are reading from that register. So it had stored 1100 that we have in our input. Let's turn off the input and see if it has really stored that value. So we turn off this input and it remains 1100. So as you can see, it has stored the value that we had. Let's try writing a different data to register 1 so that we differentiate with register 2. So register 1, let's do, we want to write data from register 2 to register 1. So let's try something simple. As you can see, it's still saving what we had. Now it's 00, so we can write data. Let's do 01, yeah, 01, wait, 0101, yeah. So 0101, you can see, if you can just focus very well, these two reds are the one which are on. So 0101. So that's what we have, and let's see if it has stored that value. So we are going to put 10, and so 10 in our register, 10 in the control, so that we see if it has stored that value. So 10 is in the control, and let's now turn the input off to see if it has saved that value. So we turn the input off, and now you can see it has stored 0101 that we had initially inputted in this register, and the one that we had in our register 2 is still saved 1100. So where can you find such a system? Let's take the example of a computer. Let's say you have fed data into your computer like a text or a photo, and you want to store it in a much you want to store it in a much safer place than the normal storage of the device. If we take this register as the safe storage rather than this one, you can take it and give it address to that register, and it will not come to this register. It will go to the register where you want it to be stored using the controls that you're seeing here. So this control, you can call it the address control, which controls which register you want to play with, either read or write data from it. So this is how computers group data and how they interpret your input. Your input can be something like for those who do coding, can be something like this. So if your code is compiled into this machine language, the computer can separate the code into something like this, where we have 4 first bits and 2 last bits. So these 4 first bits are 0000, meaning that we are putting nothing in our input. The other code, let's say, is the decoding. So 11 is for reading. So 11, as you can see here, is for reading from register 2. So this code can be interpreted that don't put any input in your circuit, but read. It's telling the computer, don't put, we are not feeding any data, but we want to read from register 2. So this is the address of register 2, and it's the reading address. So it reads the value that you are storing in register 2, and the value is 1100. If you have another like this one, 10000, let's say 10. So here in this case, we are not feeding any data, as you can see here, but we want to read. We want to read from register 1. So we want to read from register 1. We are not feeding data. We want to read from this register, and the value that we have in this register is 0101. So this is basically how how a simple code can be made and how it can be interpreted by the computer to either read or write data from any register. If you have let's take a very simple value like 1010, let's say 00. A simple code like this one, the computer will interpret it as these first 4 bits. We have 1010, which is the binary of 10, and right here we have 00. So 00 is right to register 1. So this is telling the computer to write number 10 or 1010 to register 1 and store it. So this is basically how a computer operates and how it works on a normal situation. But there are a lot of circuitry in complex circuits, but this is just to demonstrate how basic things works. So thank you very much, guys, for watching. If you find this helpful, please hit the subscribe button, and I hope to see you next time. Next time we're going to do even more complex circuit, where we're going to add even an ALU, and we'll be choosing where I will be doing some arithmetic operation, and we'll be choosing where to store this value and this value, so that you can add them, so that you can subtract them, and yeah, do all those stuff. So thank you very much, guys, for watching, and please subscribe to this channel, and yeah, hope to see you next time. Goodbye.